Hello guys, this is Sushant and welcome to your channel which is Science Genius. We have been uploading videos for your preparation for the mathematics and the physics section, and this is your physics section and the topic is current electricity. So do like our videos, do share it with your friends and do subscribe to our channel. To get the regular updates, do hit the bell icon which is just present beside the subscribe button. Also, keep watching our videos, keep learning from them and happy learning while doing so. And stay safe in the current situation. So let's get going. So in the first question, we have a wire which is of resistance 4 ohms and it is stretched twice its original length. So I need to find what is the resistance of the new wire which is being stretched. So we know that the original volume of the wire is going to be the new volume of the wire because the volume is not changing. So that means we can equate the volumes. So we know that the wire can be considered as a cylinder. So the volume of the cylinder is nothing but pi r square L. So it's going to be pi r square L, and that will be equal to the pi. So let us say this is pi r1 and this is my pi r2. So pi r2 square, and since the length is increasing twice, so we can write it as 2L. So the L gets cancelled out, the pi gets cancelled out, and I get the new radius is nothing but r1 by root 2. Now I know that my resistance is given by rho L by A. So I know that the area is nothing but the cross-sectional area. So the cross-sectional area of the wire is going to be a circle. So if I have A1, that is the area of the first wire, it is nothing but pi r square. So using the r as a r1, so that becomes pi r1 square, and the new area, it is going to be pi r2 square, but r2 is nothing but r1 by root 2, so it becomes r1 square by 2. So if I want to find r1 by r2, that will be equal to, since the resistivity is not changing because the material is not changing, the rho will be constant for both of them, so that will get cancelled out, and it is going to be the length divided by A1 divided by, now the new length is going to be twice the original length, divided by the area is nothing but, you can see it is A1 by 2, so it is half of the original one. So A1 and L gets cancelled out, and we see that this particular ratio comes out to be 1 by 4. So if I want to find the new resistance, it is going to be 4 times R1. So that means original was 4, so that becomes 16 as the new resistance. Going on to the next one, we need to find the galvanometer resistance if the given condition is that if it was connected with a 50 ohm resistor in series, it gave a range of V, and if it is connected with 500 ohm resistor, it gave the twice the range. Now in this case, we need to understand that the galvanometer has a constant current. It can handle a maximum of I current flowing through it. So if I calculate what is the current in the original case, that will be same as the current in the final one. So let us say I is the current which is flowing through the first condition, and V is the voltage which is across the galvanometer, divided galvanometer and the resistor, and the resistance is nothing but, let us say G is the resistance of the galvanometer plus 50. So you can see basically the circuit is going to be something like this. This is the resistance which is connected, and this is the galvanometer which is there. Galvanometer will have its own resistance G and the current I which is going to be flowing. This is the resistance R which is going to be changing. So this will be equal to 2 times, because the second condition the range is increased twice, so G is going to be remaining the same, plus we'll be having this as connection of 500 ohms. So these two are equated because both will handle the same amount of current at the maximum end. So this will give us the cross multiplication, V gets cancelled out, and we'll be getting G plus 500 is equal to 2G plus 100. So from this we get that G is nothing but 400. Moving to the next one, the internal resistance of a 2.1 volt cell which gives a current of 0.2 amperes through the resistance of 10 ohms. We need to find the internal resistance. So let us see the diagram for it. So we have the EMF which is 2.1 and we have the internal resistance which we need to find. So let's say R, and there is the resistance R which is capital R, which is 10 ohms, which is connected outside it, and the current through it we have been given as 0.2. So we can use the equation, that is E is equal to, that is the EMF will be equal to the total current which is flowing through both these resistors and the addition of those resistors. So that is nothing but R plus R into 0.2, that is the current. So E, we know it is 2.1. So R plus 10 is equal to 2.1 divided by 0.2. If you do this calculation, it comes out to be 21 by 2, which is 10.5. So 10 goes that side and we get R as 0.5, that is nothing but B. Moving on to the next one, we need to find what is the maximum power which can be obtained from a cell which is having EMF as E and internal resistance as R. Now this particular thing relies on the concept of maximum power transfer. What it states is that if we have an EMF E and the resistance R, the maximum power which can be transferred from this EMF to the output load is when we have both the internal resistance and the external resistance as equal resistance. If these two are having equal resistance, then only maximum power can be transferred. So that means the current which is going to be flowing through it is going to be nothing but E by 2R. So the maximum power, we know that the power is given by I square R. So it becomes E square by 4R square into the R resistance, which is this resistance. So this gets cancelled out, we get E square by 4R. That's nothing but your option C. Moving on to the next one, this is also of the same concept. The maximum current which is flowing through the resistor is 2.5. One can use M rows of cell and each row has N cells. So basically there are cells, multiple layers of cells which are connected. So in one row there are N cells, and such we have M rows which are connected, and these all are connected to an external resistance which is of 2.5 ohms. So since they are talking about maximum current, that means maximum power transfer is again into picture. So first of all, I need to find what is the resistance of these total, because they have given that each internal resistance is 0.5. So we can see that addition of all these resistance in a particular row is going to be N, so N into R. And we have this parallel combination of M such things, so it's going to be M. So the total resistance is nothing but NR upon M. Now this resistance should be equal to 2.5 because for maximum power transfer concept. So I'm going to get the first relation, that is N by M is equal to 2.5 divided by 0.5 because internal resistance is 0.5. So that comes out to be 5. Again, the next thing they have given that the total number of cells to be used is 45. That means N into M is 45. So from here we are getting N as M into M. If I substitute N in this case, I get 5M square is 45. The 5 gets cancelled, this becomes 9. M becomes 3. So I'm getting M as 3. So from substituting in this, I get the N value, which is 15. So M is 3 and N is 15. That's nothing but option. So as you guys know, for practice purpose, we also provide you questions. So these are the 2 questions for this particular video. Do let us know in the comment section what do you feel the answer to these questions to be, and the solution for them will be provided in the upcoming video. So thank you guys for watching our video. Do let us know in the comment section how do you find these videos, whether it is helping you in your preparation or not. Also let us know in the comment section what more videos or what more topics you would like us to make the video on. This will help us make more curated content for you guys and help you in your preparation. So if you're not yet subscribed to our channel, do subscribe to our channel and just hit the bell icon which is present beside the subscribe button. This will help you get in touch with the new uploads and the new contents which have been uploaded on a regular basis. Do like, do share and do subscribe. So So keep learning, keep watching, and happy learning, and stay safe. Bye.